Alright, so today we'll be doing a projectile motion practice problem. So let's say some arrow is launched at 50 meters per second, 20 degrees to its horizontal. The first thing I want to do is resolve my x and y components. And so when I do that, for my y component, I get sine theta v. For my horizontal component, I get cosine theta v. And when I compute those in my calculator, sine of 20 multiplied by 50 meters per second will give my vertical velocity b 17.1 meters per second for the vertical velocity. For our horizontal velocity, it's going to be cosine 20 multiplied by 50 meters per second, and which will be 46.98 meters per second. And I want to figure out what is the maximum height of this arrow. Well, what formula can I use? Maybe I can use final velocity squared equals initial velocity squared plus 2 times acceleration multiplied by the change in delta y. And so, I didn't have to use time for that one. And so, I know that when it reaches its highest point, it's going to be at 0 meters per second. So I automatically know final velocity is 0. And I want to solve for delta y. So this equation, in turn, equals 0. And so, since I want to figure out delta y, I minus 2a delta y on both sides, minus 2a delta y, and that equals v naught squared equals minus 2a delta y. And in this problem, initial velocity is negative, and so I know that equals negative 2a delta y divided by negative 2a. And so my delta y is going to come out to, so initial velocity squared, and the initial velocity in this problem is the vertical height because we want to know its maximum height. So we do 17.1 squared, which is about 292.4 meters per second. And remember, divided by negative 2 multiplied by acceleration, which is 9.8, will give negative 19.6. And it is also negative on top. Which will give me, so 292.41 divided by 19.6 will give my maximum height to be about 14.92 meters. And that's how you figure out maximum height for this problem. Now, what if I want to figure out the total distance traveled by this arrow? Well, I found its maximum height. Now I need to find the time for which it reaches its maximum horizontal distance. Sorry, did not mean to erase that. Alright, so I know my cosine theta v, and I know that horizontal velocity is unaffected by acceleration, so I can just do this. Vertical velocity equals the change in x over time. And I want to know how far it went, so multiply velocity times time will give me the distance traveled. So cosine theta v, which is 46.98 meters per second, and I don't know my time. How do I figure out time? Well, I can do final velocity equals initial velocity plus acceleration times time, and that's one of our kinematics formula. And one thing I know about this is that the initial velocity it's launched is cosine theta v, and when it ends, it's going to be 0 meters per second. So my final velocity is 0, and I'm solving for the time. So this in turn equals 0 minus at on both sides, which will give v naught equals at divided by a, and you get 46.98 meters per second divided by gravity give me its total time, which is 4.79 seconds. Now I'm not done yet. I need to plug that into this equation. So since ext equals delta x, I do 46.98 meters per second multiplied by the time I found, 4.79 seconds, which will give me a total horizontal distance of 225 meters. And that, ladies and gentlemen, is how you solve a projectile motion problem. Thanks for watching.